All right, guys, we're on Unit 7. This is day 3, and we're going to write explicit sequences given two terms. And it sounds like that we've already done that, but the terms we're going to be given today are not consecutive like they are in question number 1 and question number 2 right here. This part we've done before, but if they give us two non-consecutive terms, for instance, they give us, let's say, the first term, and then they don't give us, till the fifth term, we can't figure out the information that we can figure out as if they were consecutive. So for instance here, because these are consecutive terms, I can figure out number 1 if this is arithmetic or geometric. Number 2, I can figure out the common ratio or the common difference. All right, so if we look at these terms, these ones are a little bit tricky to figure out what we are doing to get from term to term. Okay. So one way we can figure it out is if we, either subtract them or divide them, okay? So if we go ahead and take 384 and we subtract 256, 384 minus 256, that is adding 128. So for instance, if I take 256 and I add 128, I get 384, but then if I add 128 again, I get 512, and this is 576. So right now, I realize that it's not arithmetic, it's geometric, okay? And so if you have to figure out what you're multiplying by, and you can't, remember that the opposite of multiplication is division. So let's take 384 and divide by 256. 384 divided by 256 is 1.5. So now let's see if this works. What if we're multiplied by 1.5? Oops. What if we multiply by 1.5? Let's see if that works all the way through. So 256 times 1.5 is 384 times 1.5 is 576 times 1.5 is 864. Okay, so we figured it out. So because we're multiplying, then this becomes geometric. Okay, and geometric formula is a sub n equals our first term, which is 256, our r, which is what we're multiplying by, which is 1.5, and then raised to the n minus 1. And there's our explicit formula. Remember, those can't be cleaned up. Okay, in number 2, it says given the sequence 8 to 6 to 4, this one's a little bit easier with the smaller numbers to figure out. Are we adding or multiplying? And I think you guys can see that you are adding a -2. 8 plus a -2 would put you at 6. 6 plus a -2 would put you at 4. 4 plus a -2 would put you at 2. So because this is arithmetic, we'll use the right formula. Our first term is 8 plus our n minus 1 in parentheses times our difference of -2. And it's an okay formula. I do like to clean them up, though. They look a lot better when they're cleaned up. And it just takes a little distributing. So we're going to go ahead and say keep our 8 plus. That's going to give us a -2n, and then that's going to give us a +2. Put the -2n first, and then the 8 plus the 2 here is going to give us a +10. And there's our formula. We could find any term that we need to. Okay. All right, guys. So the difference between today is, like I said, we're not going to have consecutive terms. Okay. So how to write an arithmetic sequence given two non-consecutive terms. We're going to determine the common difference. And since arithmetic sequences model linear functions, the common difference is the slope, like we were talking about in the warm-up today. To determine the first term, a sub 1, we could either substitute in, or depending on what term they give us, we can count backwards, okay, and compute our terms backwards instead of forwards, all right? Or we could substitute into our formula, all right? So we'll figure out depending on what information they give us. I can show you both ways. So in number 3, it says that the fourth term of an arithmetic sequence is 80, okay? And we can write it like this, like an ordered pair. The fourth term is 80, okay? And here the 12th term is 32. Okay, so notice, like, we don't know the first term, the second term, the third term, but the fourth term is 80. Okay. We don't know the fifth term, the sixth term, seventh term, eighth term, ninth term, but the 12th term is 32. So you see how they're in two non-consecutive terms. They're spaced out where we can't figure out, even though they tell us that this is arithmetic, we can't figure out what the difference is by going from term to term to term because we don't have them. So because this is arithmetic, we have to remember that our slope, okay, which we usually use m, okay, is kind of like our difference. Okay? And we're going to use the same formula, y2 minus y1 over x2 minus x1. Okay? So this is our slope, but we have to realize that it's also going to be like our difference. All right, and I'm going to go ahead and put the 80 in first, minus the 32. Because I used 80 first, I have to use 4 first on the bottom, minus the 12. 80 minus 32 is 48. 4 minus 12 is negative 8. And then when we go ahead and we subtract them, we get a difference of negative 6. Okay. All right. Now, they did give us our 4th term, so we could count backwards, and I'll show you guys how to do that. So 80 minus 6 would be 74, right? Okay. 74 minus 6 would be, oh, I'm sorry, I was going the wrong way. We're adding negative 6, so I'm going to go ahead and take that term out because that's wrong. That's the wrong way. If we were going forward, that would be. So for instance, 80 minus 6 being 74 would be here. Okay, so following the pattern backwards, I actually have to add 6 since I'm going in reverse. So that's a little tricky. Something you got to remember yet you're doing. All right. And then 86 plus 6, our second term would be 92. And then 92 plus 6 would be our first term of 98. Okay. Now, that wasn't bad because we just had to go backwards 3 spaces. All right. But if you want to use the formula, you can. And so I'll show you that. So that's a sub n equals a sub 1 plus n minus 1 times our difference because it's arithmetic. Okay. We can use either one of these points. Let's go ahead and use this one just because it has a, I guess, smaller numbers. I guess it doesn't really matter. All right. So remember 32 is like your output. So 32 will go here. Our first term is actually what we're solving for because remember, we know now that it's 98, but before we didn't. Okay. And our n is going to be that 12. And the difference we found out in the first part is negative 6. Okay. If we go ahead and clean this up a little bit, 12 minus 1 is 11, and 11 times negative 6 is negative 66. Okay. We're going to go ahead and add 66 to our 32. And 32 plus 66 is 98. And so that's how we can figure out our first term if we didn't want to do the whole working backwards. Okay. All right. So remember, we're trying to write a formula for the nth term. We now have our 2 pieces of information. And so we'll go ahead and say a sub n equals my first term, which is 98, plus n minus 1 times our difference of negative 6. Okay. And that's an okay formula. I like to clean it up though. And that's going to give us a negative 6n plus 6. All right, so a sub n equals negative 6n, and then 98 and 6 make 104. And there's our formula. Okay, so a little bit of a longer process when they don't give you those consecutive terms because you have more information to find out. All right, so let's take a look at number 4. On the main floor of the Kodak Hall at the Eastman Theater, the number of seats per row increases at a constant rate. Stephen counts 31 seats in row 3 and 37 seats in row 6. How many seats are there in row 20? So in row 3, there are 31 seats. In row 6, there are 37 seats. How many seats are there in row 20? So it's basically kind of what we have here. So for instance, we don't know the first term or the second term. but the third term is 31, fourth term, fifth term, sixth term is 37, and they want to eventually know the 20th. Okay, so again, see how there's two non-consecutive terms given to you. Okay, because they said constant rate, we know that this is arithmetic. Okay, and so we'll go ahead and say, all right, we can't figure out our difference, so we're going to go ahead and use the slope formula because slope formula is like the difference. And remember in the formula, y is to the sky, so I'll take 37 first, minus 31, and then on the bottom I have to do 6 minus 3. 37 minus 31 is 6, and 6 minus 3 is 3, and 6 divided by 3 is 2. And that is my difference. I know it's a slope formula, but remember, arithmetic sequences model linear functions. Okay. All right, so again, we could work backwards and say, okay, well, if this was 31, and we would have added 2 to get to that, then this has to be 29. 29 plus 2 would be 31, right? And so we'll keep going back until we can figure out that this is a 27, okay? Or we can use our formula, okay? And our formula says a sub n equals a sub 1 plus n minus 1 times our difference, okay? Sometimes it's not that close to get back to the first term, and so this way you have to know it as well, okay? I'm going to go ahead and use 3 and 31, and so 31 is like my output. We don't know the first term. That's what we're trying to solve for before we knew it was 27. N is like my input, which would be 3. And then my difference is 2. If we clean this up a little bit, 3 minus 1 is 2, and 2 times 2 is 4. And we'll go ahead and subtract 4. And 31 minus 4, you guessed it, is 27. And so that's how you would do it algebraically. All right. Now that we have that, guys, now we can go ahead and write our formula. So we have a sub n equals a sub 1, which is 27, plus n minus 1 times my difference of 2. And that's a fine formula. We could use it if we wanted to, or we could clean it up and write a nicer one just to practice. All right, a little distributing, that would be a 2n. That would be a minus 2. Okay, I'll put the 2 in first, and the 27 minus 2 would be a positive 25. Okay, and now that I have my formula, remember the question that they wanted to know, how many seats are there in row 20? So we'll say a sub 20 equals 2 times 20 plus 25. And so a sub 20 comes out to equal 65. There are 65 seats in the 20th row, okay, with that pattern. All right, very good, guys. All right, let's go ahead and I'll see you guys on the back side of notes.